Every day, ports like Shanghai shift over 150,000 containers, fueling $15 trillion in global trade. Yet the true limit isn't just speed, it's raw physical capacity. When Port Klang managed 734 container moves in a single hour, it exposed the razor-thin margin separating smooth flow from collapse. So how do the world's ports race the clock and physics itself to unload a 10,000 container ship in a single day? The answer reveals a hidden battle shaping everything you buy. Shanghai's container terminals pulse around the clock, orchestrating the passage of more than 55 million TEUs in 2025 alone. That's nearly 150,000 containers routed through a single port every day, each one tracked, sorted, and dispatched with barely a pause. Singapore, the next busiest hub, processed over 44 million TEUs last year, its cranes and automated vehicles moving in seamless coordination to keep up with surging demand. Together, these giants stand at the heart of a global trade network valued at $15 trillion annually, a flow so immense that even a brief slowdown can ripple across continents. Every container represents a promise: groceries on supermarket shelves, electronics in store windows, raw materials feeding distant factories. Port authorities know that schedules leave no room for error. As megaships grow larger and trade volumes climb, the challenge is not just to move containers quickly, but to prevent the entire system from grinding to a halt. The world's busiest ports now race against mounting pressure, balancing relentless growth with the hard limits of space, machinery, and time. For every minute lost, thousands of containers wait, and global supply chains edge closer to congestion. In this environment, efficiency is not just a goal, it is the only way to keep the world supplied. At Port Klang, Malaysia, a team of operators and engineers once pushed the boundaries of what manual coordination could achieve. In a single hour, 9 gantry cranes lifted and moved 734 containers from the deck of the MV CSECL Pusan, a 9,600 TEU vessel. Each crane performed with near-flawless timing, working in tight formation along the ship's 400-meter length. The choreography demanded constant radio chatter, precision spotting, and split-second judgment as containers weighing up to 40,000 pounds swung overhead. For that hour, the terminal's cranes averaged more than 80 moves each, an achievement that stands among the highest ever recorded in a hybrid manual setting. But even at peak performance, there are limits that no amount of teamwork can overcome. The physical size of ultra-large container vessels means only 6 to 8 cranes can work side by side on a single ship, no matter how skilled the crew. Every additional crane risks interference, collisions, or diminishing returns as operators fight for space. Mechanical speeds reach their ceiling, but bottlenecks appear on the ground. Trucks must arrive in perfect sequence, yard space must be available, and every move must fit into a carefully orchestrated plan. Manual and hybrid systems can deliver astonishing bursts, but sustaining that pace for the full 10,000 container unload is nearly impossible. To move beyond these limits, ports must look beyond raw power and coordination, toward new systems that can synchronize every element, every second, with machine-level precision. Unloading a 10,000 container ship in a single day remains out of reach for most ports, not because cranes are too slow, but because of the hidden obstacles that stack up minute by minute. Even at the world's most advanced terminals, the process stretches over 24 to 72 hours. Each crane cycle averages 2 to 3 minutes under ideal conditions, but those numbers rarely hold steady over thousands of moves. Wind gusts strong enough to sway a container can force operations to pause for safety, sometimes for hours. Rain and fog reduce visibility, slowing precision work and pushing operators to double-check every move. Automated systems are not immune. Optical character recognition scanners, designed to read container IDs in seconds, sometimes misread or mismarkings, requiring manual intervention. Every misidentified box or misplaced container can trigger a rehandle, where a container must be moved again to reach the correct one underneath. Across a full ship, these rehandles account for 5 to 10% of all moves, adding hours to the clock. Documentation delays build up as customs checks, paperwork errors, or incomplete digital records force containers to wait in limbo. For the teams on the ground, whether monitoring screens in a control room or coordinating trucks in the yard, these slowdowns are a constant battle. The promise of a one-day unload remains just out of reach, not because the machines lack speed, but because the entire choreography is vulnerable to friction at every step. At Qingdao's new Chanwan container terminal, the pace of progress is measured in seconds, not years. On January 1st, 2026, the port set its 12th world record, averaging 60.9 container moves per hour for a single crane. Each 40,000-pound box lifted, swung, and landed in just under a minute. This isn't the work of a crowded dock. Instead, a handful of operators like Li Wei guide the operation from a quiet control room, their eyes on digital dashboards rather than steel cables. Where 60 workers once hustled along the quay, now just 9 oversee the entire discharge of a ship. Every crane, every automated vehicle, every twist-lock robot moves in step with software that plans, tracks, and adjusts in real time. Across leading terminals, full automation now delivers a new standard: 58 container moves per hour per crane, a 50% jump over manual operations. The numbers tell the story: fewer people, more containers, and a relentless drive for speed. For Li Wei and the automation crew, the record isn't just a headline. It's proof that software and sensors can outpace even the most seasoned hands, turning what was once a logistical marathon into a race of milliseconds. Hamburg's container terminal Altenwerder stands as a showcase of European engineering ambition. Over 1 billion euros has been invested to transform the port into a near-silent theater of remote-controlled machines. Operators like Dr. Katharina Muller now guide towering gantry cranes from ergonomic control rooms, far from the wind and noise of the quayside. Each crane's movements are coordinated by the terminal's proprietary TLS software, which orchestrates every lift, swing, and set-down in a precise ballet with automated guided vehicles below. This system not only reduces operator fatigue, but also enables a single person to oversee multiple cranes, raising productivity to levels once thought impossible. Across the North Sea, Dutch engineers at Rotterdam's Maasvlakte 2 terminal have taken autonomy even further. Here, driverless ship-to-shore cranes glide along the berth, each guided by GPS and a web of sensors. Containers are transferred from vessel to shore without a human hand on the controls, then whisked away by fleets of AGVS that navigate the sprawling yard with millimeter accuracy. The result is a terminal that operates around the clock, unaffected by shift changes or the limits of human endurance. In China, the Yangshan Deepwater Port's Phase 4 terminal pushes the envelope with dual-trolley, dual-container gantry cranes. These machines can lift 2 containers at once, doubling the pace of yard operations. Backed by a fleet of 28 automated key cranes and more than 100 AGVS, Yangshan's system is built for scale, handling the world's largest ships with a speed and efficiency unmatched by manual operations. Each of these flagship projects represents a different path to the same goal: moving more containers, more quickly, through the heart of global trade. Every movement on the dock now feeds into a digital nervous system, where the Terminal Operating System, TOS, acts as the conductor. This software doesn't just track containers, it predicts bottlenecks, reroutes automated vehicles, and sequences every crane lift to match the minute-by-minute needs of the world's biggest ships. Sensors monitor wind, weight, and vibration, sending streams of data into the TOS, while AI maintenance modules scan for early signs of trouble. At Qingdao's automated terminal, algorithms can flag a failing gearbox or a worn cable up to 72 hours before it interrupts the flow, allowing engineers to swap out parts before a single container is delayed. China's investment in this software-driven yuan-matched future is unmatched. 52 fully automated container and bulk terminals now operate across the country, each one wired into a network designed to keep pace with ever larger ships and tighter schedules. This scale gives Chinese ports a commanding lead in throughput and resilience, with records set and broken by digital coordination as much as by steel and concrete. Yet there are new lines of friction. In October 2025, the United States imposed steep tariffs, up to 25% on Chinese-made container cranes, citing concerns over supply chain security and foreign control of critical infrastructure. American ports began looking to European suppliers, but capacity and cost remain obstacles. As the world's docks become ever more dependent on code, sensors, and predictive AI, the race is no longer just about moving boxes. It's about who controls the brains behind the choreography and whose rules shape the arteries of global trade. Automation now moves thousands of containers with just a handful of operators, but every leap in speed exposes new vulnerabilities, labor shifts, supply choke points, and geopolitical risks. The future of global trade hinges not on how fast we unload ships, but on how resilient we make the system. What do you think?